In this module, we shall be able to know what is digital photography, what are the characteristics in digital photography, learn about image compression, file format and its application. Digital photography. Digital photography is in no way different or separate from conventional film, or as we sometimes say, analog photography, except for the following things: the image capturing medium, the image capturing principle or technique, the image storage device. A digital camera also consists of a light constricted camera body as a film camera with a lens, an aperture mechanism and a shutter control to control exposure. There are various models of compact digital cameras as well as digital SLR cameras with varying features. But whatever be the model of the digital camera or the manufacturer, it works on the basis of same principle of an analog or a film camera. So someone familiar in using a film camera can very well depict good pictures with a digital camera. Therefore, as we have explained the basic principles of photography in earlier lessons, we need not repeat them as they are true for digital photography also. The deviations will be clarified as we go into the details of the topic afterwards in this lesson. Advantages of digital photography over conventional photography. In modern world of imaging, digital photography certainly have some advantages over conventional photography. The major among them are film photography. Films have limited exposure capacity like 24 or 36 frames in a roll of film. Then in case of digital photography, digital memory cards can store much more number of images. This gives us an opportunity to shoot more pictures, and since the card can be reused, the cost of divulging is reduced to minimal. In case of film photography, images exposed through films could not be seen unless the film is developed or printed. And in case of digital images, the images can be seen instantly on the camera LCD display. Since we have an immediate feedback of the image, we can correct the focusing, exposure or composition if required. Then in case of film photography, once a particular film is loaded, the film speed cannot be changed and exposure should be made accordingly. While in case of digital photography, film speed can be changed easily in a digital camera just by pressing buttons or rotating a dial as desired. Now in case of film photography, films are manufactured for a particular color temperature, daylight type or tungsten light type. While in case of digital, color temperature can be adjusted on a digital camera according to external light condition or the requirement. Now again in case of film photography, video is not possible in case of film cameras, while in case of digital cameras, video can be shot. Again in case of film photography, preserving a film property is not easy, and editing an analog image in a dark room needs great amount of expertise. While in case of digital, cataloging and editing digital is much easier on digital media. Now we will talk about the digital camera sensors. Digital cameras are the most popular devices used to expose and capture a digital image. Although we can capture digital images by scanning also, but understanding the functioning of the digital sensor, which is a CCD or CMOS, is the first step towards learning digital photography. Fundamentally, a charge coupled device, CCD, is an integrated circuit etched onto a silicon surface, forming a grid of several million tiny dots, which are called photosites, or light sensitive elements called pixels. Photons incident on this surface generate charge that can be read electronically and turned into a digital copy of the light patterns falling on the device. CCDs come in a wide variety of sizes and types and are used in many applications, from cell phone cameras to high-end scientific applications. Each pixel in a CCD can remember how much light is received in a given period of time when a camera shutter is pressed to expose a photograph. Each of these picture elements are uncovered to collect and store photons. All the exposure completes the camera closes at each photo site and assesses the contents. The comparative amount of photons in every cavity is organized into different intensity stages. There are three significant qualities to each sensor, that is resolution, size and the quality. The function of a CCD can be seen as a selection of pixels collecting photons. Characteristics and type of digital image. A digital image is an exemplification of a 2D image using binary numbers, that is 0 and 1. Dependent on image resolution, it is fixed or not. It may perhaps be of vector or raster type. The word digital image generally denotes to raster images, also called as bitmap images. In digital imaging, a pixel or picture component is a solitary point in a raster image or the minimum addressable screen element. It is the least unit of picture that can be demonstrated or controlled. Then is each pixel has its own address like x by y axis of a graph. More pixels characteristically offer more exact representation of the original. The strength of each pixel is inconstant. In color image systems, a color is characteristically signified by 3-4 component intensities such as RBG or CMYK. Resolution. Resolution is a dimension of sample concentration. Resolution of bitmap images gives a connection between pixel dimensions and physical magnitudes. The most commonly used measurement is PPI, that is pixels per inch. The difference between PPI or DPI is the variance between pixels and dots. Pixels can denote manifold values at the same time as a dot in a monochrome spot of ink or toner of a single pigment as produced by a printer. Printers use a method called half toning to make a uniform configuration that imitates a variety of intensity stages. Resolution is simply the number of pixels. As more pixels we have, then the fine-grained details we can theoretically record. Any resolution above 2 or 3 megapixels, that is billions of pixels, will be enough for displaying on a screen. But higher resolutions come into play for two important applications, that is printing and the cropping. To have a good reproduction quality, it is usually estimated that 240 and 300 pixels should be used for every inch of papers, dots per inch or DPI, which will give a natural limitation to the biggest size one can print. For example, a 6 MP image of sizes 2000 into 3000 pixels can be reproduced at a maximum size of 12.5 into 8.3 inches at 240 DPI. It is possible to print bigger by either lowering the DPI or artificially increasing the resolution, but the image quality will be poor. Having an advanced resolution permits us to print bigger. Scaling or resampling. When we require generating an image with diverse dimensions that we possess, then we can measure the image. A dissimilar name for scaling is resampling. When algorithms attempt to restructure the original uninterrupted image and produce a new sample grid, the method of reducing the raster dimensions is called decimation, scaling image down. This can be completed by averaging the values of source pixels contributing to each output pixel. When we intensify the image extent by essentially want to produce sample points among the original sample points in the original raster, this is done by interpolation, scaling image up, the values in the sample grid, effectively guessing the values of the unknown pixels. By the digital zoom of a camera, the camera is using interpolating to guess the values that do not exist in the image. Capturing an image at the extreme analog zoom level and undertaking the post dispensation of cropping and rescaling on the computer will give equal or better results. Bit depth. The values of the pixels must be stored in the computer's memory. It means that the data eventually need to end up in a binary representation. The spatial continuity of the image is approximated by the spacing of the samples in the sample grid. The values we can represent for each pixel is determined by the sample format chosen. Bit depth is determined by the integer of bits used to describe each pixel. So, bit depth enumerates the number of unique colors available in an image color palette in terms of the number of zeros and ones or bits which are used to postulate each color. This does not mean that the image essentially uses all of these colors, but that it can, as an alternative, specify colors with that level of accuracy. For a grayscale image, the bit depth measures the number of available unique shades. Images with greater bit depths can encrypt extra shades or colors since there are more permutations of zeros and ones available. Bit depth is proportional to the number of tones, grayscale or color, that can be represented. Digital images can be created in black and white, that is bitonal, grayscale or color. A bitonal image is represented by pixels consisting of 1 bit each, which can represent 2 tones, typically black and white, using the values 0 for black and 1 for white or vice versa. A grayscale image is composed of pixels signified by manifold bits of information, typically extending from 2 to 8 bits or more. Floating point. Certain image formats used in research and by the movie industry store floating point values, both normal 32-bit floating point values and a special format called half, which uses 16 bits per sample. Floating point is advantageous as a working format because quantization and computational inaccuracies are retained to a minimum until the final render. Floating point demonstrations often include HDR or high dynamic range. High dynamic range images are images that comprise sampling values that are whiter than white. HDR allows representing the light in a scene with a greater degree of precision than LDR, low dynamic range images. Next is image compression. Bitmap images yield a lot of memory. Image compression moderates that the amount of memory needed to store an image. For instance, a 2.1 megapixel 8-bit RGB image occupies 1600 into 1200 into 3 bytes, that is equal to 57,60,000 bytes, which is equal to 5.5 megabytes. This is the uncompressed size of the image. Compression ratio is the ratio among the compressed image and the uncompressed image. If the example image quoted above was stored as a 512 KB JPEG file, the compression ratio would be 0.5 MB is to 5.5 MB, which is equal to 1 is to 11. Lossless image compression. When an image is losslessly compressed, recurrence and probability is used to characterize all the information by means of less memory. The original image can be restored. One of the unpretentious lossless image compressed methods is run length encoding. Run length encoding encodes successive analogous values as one perfunctory in a data stream. A black and white image of a house has been compressed with run length encoding. The bitmap is considered as one long string of black or white pixels. The encoding is how many bytes of the same color occur after each other. It will further reduce the amount of bytes taken up by these 72 numerical values by having maximum span length of 15 and encoding longer spans by using multiple spans separated by 0 length spans of the other color. Next compression type is lossy image compression. Lossy image compression takes benefit of the human eye's capability to hide deficiency and the fact that certain types of information are more significant than the others. Modifications in luminance are, for example, seen as more noteworthy by a human witness than change in hue. JPEG is a file format applying compression based on the discrete cosine transform, that is DCT, collectively with lossless algorithms. This delivers worthy compression ratios. The way JPEG works is superlatively matched for images with constant tonal ranges like photographs, logos, scanned text and other images with lots of sharp contours, lines will get more compression artifacts than photographs. Lossy compression algorithms should not be used as a working format. Only final copies should be saved as JPEG since loss accumulates over generations. Next is different types of file formats and their applications. Several applications have their specific internal file format, whereas other formats are more appropriate for transaction of data. List some common image formats. Vector file formats. First is extension, name and the notes. Extension type is .ai. The name for this is Adobe Illustrated Document. It is native format of Adobe Illustrator based on EPS. Then next is EPS type extension, which is encapsulated PostScript. This is industry standard for containing vector graphics in print. Then is PS, which is PostScript. It is vector based printing language used by many laser printers used as electronic paper for scientific purposes. Very commonly known by everyone is PDF, which is portable document format. It is the modernized version of PS adopted by the general public as electronic print version. The next is SVG, which is scalable vector graphics. Next is SWF, that is shockwave flash. It is a binary vector format with animation and sound supported by most major web browsers. Raster file formats, the extension, name and the notes. First is JPG, also known as JPEG, which is Joint Photographic Experts Group. It is lossy compression format well suited for photographic images. Next extension is PNG, which is Portable Network Graphics. It is lossless compression image supporting 16-bit sample depth and alpha channel. Next is GIF extension, graphics interchange format. It is 8-bit indexed bitmap format, is superseded by PNG on all accounts but not animation. Then is EXR, which is also known as OpenEXR. It is high dynamic range format used by movie industry. RAW, which is raw image file. It is direct memory dump from a digital camera. It contains the direct imprint from the imaging sensor without processing with white point and gamma corrections. Different cameras use different extensions. Many of the derivatives of TIFF examples are .NEF, .RAF and .CRW. .DGN, that is digital negative, a subset or clarification of TIFF created by Adobe to provide a standard for storing RAW or raw files, as well as exchanging raw image data between applications. Next extension is TIFF or TIF. It is tagged image file format. Next image format is PSD, which is Photoshop document. It is native format of Adobe Photoshop, allows layers and other structural elements. And last format is XCF, which is GIMP project file, which is GIMPS native image format. Levels and curves. Curves. It is simple information of layers and masks. This climbs to something like 80%. Even though curves are comparatively direct, there is a basic form of the tool which, while losing some power, is often sufficient. Levels. Levels and curves transform exposure and, by extension, contrast. In order to be used efficiently, it is essential to have a respectable understanding of the histogram. As you may recall, we said in the histogram lesson that a perfect histogram is one which has a bell shape, tapering off in both directions and ending exactly at the edges, which correspond to pure white and pure black. You don't want it to end after the right edge, for instance, because it would mean that you are losing information and getting pure light. It means that there are no really bright values in the image, which will make it appear dull and washed out, lacking contrast. Levels essentially resize the box so that the histogram fits into it perfectly. There are three controls: black, grey and white points. Let's forget about grey for now and focus on black and white. If you slide them around, they will describe the new edges of the box in which the histogram subsets. Image noise. Image noise is the digital corresponding of film grain for analogous cameras. Alternatively, one can contemplate of it as analogous to the delicate background hiss perceived from the audio system at full volume. For digital images, this noise seems as random flecks on an otherwise smooth surface and can significantly destroy image quality. Even though noise regularly reduces from an image, it is occasionally required since it can increase an old-fashioned grainy look which is suggestive of early film. Some noise can also increase the apparent sharpness of an image. Noise rises with the sensitivity setting in the camera. Length of the exposure, temperature and even differs amongst different models. Now, various lenses in the digital camera. The lens is the second constituent of any camera. It is an optical device which receives scattered light rays and focuses them precisely on the sensor. The quality of the glass and the accuracy of the lens will be particularly imperative in determining the quality of the final image. Focal length denotes roughly to the zoom level or angle of view of the lens. It will have its own lesson in a few days, as it can be an unexpectedly complicated subject. A focal length is generally expressed in millimeters, and you should be cognizant that the resulting angle of view actually depends on the dimensions of the sensor of the camera on which the lens is used. This is called the crop factor. For this reason, we often give 35 mm equivalent focal length, which is the focal length that would offer the similar view on a 35 mm camera. The historic film SLR format allows us to make expressive compressions. If there is a simple length, that is 24 mm, then the lens doesn't zoom and it is often called a prime lens. If there are two numbers, example 18 to 55 mm, then you can see the use of lens at any focal length in that range. Compact cameras often don't provide focal lengths, but basically the range, for instance 8x, this means that the long end is 8 times longer than the wide one. So the lens could be a 18 to 144 mm or 35 to 280 mm, etc. The aperture is a very substantial concept which we will talk about in much detail later on. The aperture is an iris in the center of the lens which can close to gradually small sizes, restraining the amount of light which gets on the sensor. It is stated to as f number, for instance f by 2.8. To make things inferior, it is quite counterintuitive. As the smaller the number, the bigger the aperture. For now, we don't have to worry about this too much. The significant number on a lens is the maximal aperture. The lower the better. Professional zoom lenses often have f by 2.8 maximal apertures, and economy consumer lenses have ranges such as f by 3.5 to 5.6, meaning that at the wide end the maximum aperture is f by 3.5 and at the long end it is f by 5.6. Aperture can be close to tiny levels, usually at f by 22. The important factors in digital cameras, first is the shutter. The most essential is probably the shutter. Think of it as a curtain in front of the sensor. When we press the trigger, the curtain opens, exposes the sensor to light from the lens, then closes again after a very specific amount of time, often a tiny fraction of a second. Most shutters operate between 30 seconds and 1 by 4,000th of a second. That duration, the shutter speed, is one of the three very significant exposure factors along with aperture and ISO. The best place to see the shutter speed setting on the camera is in the viewfinder. Half press the shutter button activated the camera and the viewfinder, and we can see the shutter speed, which is the first number at the button. Focusing, a focus detector used to derive the autofocus motor in the lens. There are two contending technologies, contrast detection and phase detection, with one at the moment an edge for the later, which explains why DSLRs tend to focus faster than compact cameras. These systems have a habit to vary greatly between basics and advanced bodies, but it should be noted that they all need rational amounts of light to work appropriately. Memory cards, an approach to store the image just generated back in the days of film. This was just a lever to advance the roll to the next unexposed frame. Now it is a pipeline which ends up in the memory card that the camera is using. If we are shooting JPEG instead of RAW, there is an additional stage where the internal computer executes all sort of black magic on the image to output a ready to view JPEG file. Viewfinder, way to frame or compose the image. It can be assembly of things, optical or electronic viewfinder, LCD screen or even ground glass. Here too, DSLRs have an edge, as an optical viewfinder allows through the lens viewing and immediate feedback, while electronic viewfinders, a LCD screen inside a viewfinder, and LCDs often have limited resolution and slight updating delays. Exposure. In order to keep things short, we divide this vast subject into small parts. Here we will see what exactly exposure is and how we can use 3 camera controls to modify it. Afterwards, we will talk about a very important tool for revising exposure, the histogram. Consequently, we will talk about each of the 3 controls, that is shutter speed, aperture and ISO, in more detail. Exposure basically is the amount of light to which the sensor is exposed. First, ISO. The ISO speed, also occasionally known as sensitivity, is alternative measure factor to control exposure in any digital camera. ISO is one of the essential differences between film and digital. It is a physical property of the film we are exhausting, and the only way to modify it is to change to a new roll, not the most appropriate one. With digital, we can easily change ISO between shots merely by turning a wheel, which permits flawless adaptation to the current light conditions. For those who shot film a long time ago, you must have used diverse words for sensibility. ASA or DIN. The first is exactly the alike than our current ISO. It simply changed name when it became homogeneous. The later uses another logarithmic scale and is absolutely outdated. Transformation between the two is quite straightforward though. Now ISO speed and the aperture. If the ISO speed is 100, the aperture size is f4. If ISO speed is 200, aperture is 5.6. If ISO speed is 400, aperture is f8. If ISO speed is 800, it is f11. If ISO is 1600, aperture is f16. If ISO is 3200, the aperture size is f22. A digital camera, like a film camera, also contains light body with a lens, an aperture mechanism and a shutter control to control exposure. Second, a digital image is a depiction of a two-dimensional, that is 2D image using ones and zeros, that is the binary. Bit depth is determined by the number of bits used to explain each pixel. So bit depth computes how many unique colors are accessible in an image color palette in terms of the number of zeros and ones or bits which are used to depict each color. Fourth, ISO is one of the important dissimilarities between digital and film cameras.